In the second part of the lesson, we are going to take a look at what electrolytes are. So, some things that dissolve are electrolytes, and some things are not. So it says all solutes, that means everything can dissolve, that dissolve in water are fit into one of two categories. They're either electrolytes. So an electrolytic solution has a solute that dissolved into a solvent that enables an electric current to pass within a solution. Okay, so some things that make electrolyte solutions include ionic salts, right? Ionic compounds, strong acids, and strong bases. These make electrolytic solutions. So that's because they dissociate or ionize in the case of acids while dissolving. So all of our strong bases are just ionic compounds anyway, right? These strong bases are a type of ionic salt, right? So strong bases are ionic salts that end in OH, right? Strong acids ionize in the same way. They break up into H plus ions and OH minus ions. So strong acid would be H and something, right? Strong bases would be something and OH. It says, note, electrolytes increase the boiling point and decrease the melting point of the solvent, right? So they change the properties. They increase the boiling point and decrease the melting point of the solvent. That's why we use ionic ionic salts to ice our driveways and to salt our driveways in winter. So we salt our driveways to decrease the melting point, right? We want our snow to be melted at temperatures underneath, like below 0 degrees. Non-electrolytic solutions are solutes where have solutes that are dissolved in a solvent which does not enable an electric current to pass within the solution. And the solute is a non-electrolyte, right? So these are all going to be covalent or molecular. They mean the same thing, right? Compounds, right? Except for acids. Okay, so it says sugar. Sugar is a molecular or covalent compound. Will dissolve in water because it contains polar bonds, which are able to hydrogen bond to water. The entire sugar molecule becomes hydrated. There are no free ions, so the solution does not conduct electricity. Okay, so we can use electrolyte solutions to run electric current through, but we can't use the non-electrolytic solutions. So the modern theory of electrolytes is electrolytes in solution exist as ions. An ion is an atom or group of atoms which has an electric charge. In a solution, the total positive ionic charge equals the total negative ionic charge. So in other words, the solution is neutral, but the individual particles are charged, right? So solution is neutral, particles are charged. So we have strong electrolytes and weak electrolytes, right? Strong and weak. Strong electrolytes is an electrolyte which completely dissociates or ionizes in a solution, and producing electricity is a strong electrolyte. So that means that if we add salt to water, all of the salt turns into ions. 100% of the NaCl turns into ions. None of it stays together, right? So long as it's under its saturation point. Okay. Same with hydrochloric acid. All of the hydrochloric acid turns into ions. Weak electrolytes are electrolytes which do not completely dissociate or ionize in solution. These substances produce aqueous solutions that conduct electricity, but only very weakly. So if you put a light bulb in a circuit and you run it through a strong electrolyte solution, you will get, this is a bad version of a light bulb, an old-timey light bulb, right? You will get very bright light. But if you do the same thing to a weak electrolyte solution, again, get ready for the bad light bulb. Okay, you're only going to get very dim light. Okay, some examples of weak electrolytes: acetic acid, vinegar. So you can, if you're good with the batteries and wire, you can make an electric circuit with a light bulb and a pickle. You can have, because pickles are made with vinegar, so pickle is mostly acetic acid, and you can get the light bulb to glow, but like pretty dimly, right? So acetic acid is an acid, vinegar is an acid that not 100% becomes ions, right? Most of it stays like this. Okay. And we have two arrows here because it sort of goes back and forth, right? Next year, you'll talk a little bit more about this. This is an equilibrium arrow, but it means that the chemical reaction can go two ways. So some will exist as vinegar not ionized, and some will exist as vinegar ionized. Okay, it says the ionization of acetic acid. Oh no, my beakers didn't show up. Hold on. I'm going to redraw my beakers. That's what they're supposed to be. The ionization of acetic acid is written with a double arrow to show that is a weak electrolyte. So anything that you see with the double arrow is a weak electrolyte. That is, the reaction can occur in both directions. Initially, the number of CH3COOH molecules break up into those ions. That would be the acetate ion and the hydrogen ion. And as time goes by, some of the ions reform into an acetic acid molecule. So let's show you what that looks like. So when strong electrolytes like HCl are in solution, hold on, let me draw the little, okay, so we have a container that's full of the solution. A strong electrolyte would be, for example, HCl. HCl, when we make it a solution, will be full of H pluses and Cl minuses. Like the whole thing. right? Everything is ion, so 100% ions. Okay, a weak electrolyte, like acetic acid, okay, is mostly, will have some where it's the molecule and some where it's the ions. Oops. Right? Some exist as ions, but some exist as molecules. A non-electrolyte would be like sugar. C11, C12, H22O11. That's sucrose. In other words, table sugar. Right? If you put that in solution, it's just going to separate from its friends. But it's not going to turn into ions. Just going to stay as molecules. Okay, so this would be less than 100% ions. And this would be 0% ions. So examples of strong electrolytes include hydrochloric acid, HNO3, which is nitric acid, HClO4, which is perchloric acid, and NaOH would be sodium hydroxide. Okay, very important that you have a sense of, and all ionic compounds. Okay, very important that you have a sense of strong acids, strong bases, strong electrolytes. Okay, so it says memorize this chart. I don't like telling you to memorize things, but you should be able to pick out on a multiple choice quiz what is a strong electrolyte or what is a weak electrolyte. Some common weak electrolytes include vinegar, acetic acid, hydrofluoric acid, nitrous acid, right? So nitric acid, NO3, is strong, and nitrous acid is weak. Ammonia, this one is very important, and water is a very weak electrolyte. Non-electrolytes include urea. This is in urine. Methanol, ethanol. So these are small alcohols. Any alcohols. Right? Alcohols. Glucose, C6H12O6. And sucrose, C11. No, did I mess this up? Yes, it's C12. C12H22O11. Brain, what are you doing today? C12H22O11. Okay. Right? And all of these have some sort of C something, H something, O something pattern. Okay? So you don't need to know the exact formula, although you should know the formulas for these last two. Otherwise, you don't need to know the exact formula. Anything that has a CHO pattern as part of its chemical formula is going to be something that's not going to turn into an electrolyte, right? To turn into electrolytes, these guys, they start with H or a metal. Okay. Conductivity. So I'm going to try to post a video of this. This is kind of cool. So you can tell whether something is an electrolyte solution, a strong electrolyte solution, a weak electrolyte solution, or a non-electrolyte solution by doing a conductivity test, or also sometimes called a circuit test. How can one determine whether or not a solution contains an ionic substance or a covalent substance? A solution that contains ions, if a solution contains ions, the solution will conduct electricity. So this has no ions, okay? This is the light bulb is off, right? This light bulb has no light, okay? Why? Because there's nowhere for the electricity to go once it hits the solution, because there are no ions to carry the electric signal. Okay, this is no electrolytes. This is a weak electrolyte. So this would be something like what you would see with vinegar. Okay, the light bulb is dim. Right, it makes a little light. Light bulb is dim, but not very much. And this one would be a strong electrolyte, like HCl. And here you can see that the light bulb is bright. Okay, so the light bulb in a strong electrolyte solution, because it can conduct a lot of electricity, because there's a lot of ions. So a lot of the electrons make it to the light bulb, and then, of course, the light bulb can be very bright. Okay, so if a solution contains ions, the solution will conduct electricity. If it does not contain ions, it will not, right? That's why if it has no electrolytes, okay, no light bulb, no light. Solutions of ionic compounds are most often electrolytic and produce ions which will conduct electricity. Solutions of covalent compounds are most likely non-electrolytic, right? So basically, ionic, light. Covalent, no light. Easy to tell the difference between the two. Okay, so that is the lesson about electrolytes, and we'll see you for the homework.